The most evident astronomical phenomenon, observable by humans over every period, is the apparent motion of the Sun in the sky. A simple observation, day after day, season after season, can reveal its periodicity, which closely influences the human activities on the Earth. Since the heliocentric revolution, we know the Earth revolves around the Sun with an elliptical orbit, and the Sun is placed in one focus of the ellipse, as expressed by Kepler's first law. The orbital plane, which contains the Sun and the Earth, is called ecliptic. The Earth's revolution is completed in one sidereal year, or 365 days and 6 hours, measured with respect to the faraway stars, assumed in a fixed position. If we measure the period of revolution through two consequent passages of the Sun at the same point, for example the vernal equinox, its length is slightly shorter, 365 days and 5 hours, and we call it solar or tropical year. At the same time, the Earth spins around its axis, causing the alternation of daylight and night hours. The sidereal day lasts 23 hours and 56 minutes, while the solar day is 24 hours. The Earth axis is tilted of around 23 degrees with respect to the vertical to the ecliptic. The difference in inclination determines a different incident angle of the solar rays on the surface of the Earth, giving rise to the seasons. The sun rays fall perpendicular to the surface of the Earth at the equator on the days of the equinoxes, days in which the hours of daylight equal the hours of darkness. About 3 months later, the sun rays fall perpendicular at the tropics. In June, to the Tropic of Cancer in the Northern Hemisphere. In December, to the Tropic of the Capricorn in the Southern Hemisphere. In this way, we have the summer solstice in June in the Northern Hemisphere, and the winter solstice in the South, and the winter solstice in December in the Northern Hemisphere, and the summer solstice in the South. At the summer solstice, the hours of daylight are longer than the hours of night. To the contrary, at the winter solstice, the night is longer than the daylight. Let's now take into consideration the Northern Hemisphere. The spring equinox falls around the 21st of March, and the summer solstice on the 21st of June. Between March and June, the hours of light increase and reach the maximum the day of the summer solstice. Between June and September, the hours of daylight shorten until we reach the autumn equinox, around the 23rd of September, in which the hours of light equal the hours of darkness. Days keep getting shorter until the winter solstice, around the 21st of December, beyond which the hours of light increase again. For this reason, the winter solstice always had a certain importance on human culture and festivals. At the spring equinox, the sun rises exactly at the east and sets exactly at the west, its maximum altitude in the sky depending on the latitude on Earth of the observer. But during the course of the year, due to the inclination of the Earth axis, the sunrise and sunset points change. The sun rises at the south of east and sets at the south of west as we approach the winter solstice, reaching its smallest altitude on the day of the solstice. In a similar way, it rises to the north of east and sets to the north of west as we approach the summer solstice. On the day of the summer solstice, the sun reaches its highest altitude in the sky at midday, which, for latitudes higher than the tropic, is always less than 90 degrees above the horizon, the so-called zenith. The range of the sunrise points along the arc of the horizon determines the solar amplitude. This angle decreases as we go towards more equatorial latitudes. At the equator, the sun always rises at the east and sets at the west. While the passage at the east on the days of the equinoxes occurs rapidly and only on the given day, The Sun appears very close to its sunrise points at the solstices, also on the days before and after the given day. This is the origin of the word solstice, which literally means stand still. The Sun at sunrise seems to stop for some days and not move ever farther towards the north or the south. The maximum height of the Sun in the sky at midday, the altitude at the culmination, depends on the latitude of the observer. At the Tropic of the Cancer, the Sun reaches the zenith on the day of the summer solstice. At latitudes lower than the tropic, the so-called tropical zone, the Sun reaches the zenith before the summer solstice. This phenomenon is called zenith passage. In the following days, the Sun crosses the zenith and culminates at north. Following the summer solstice, the Sun inverts its apparent motion, crossing the zenith again at the second zenith passage of the year. As we approach the equator, the interval between the two zenith passages increases, until, at the equator, the zenith passages occur at the equinoxes. If the solar amplitude decreases towards the equator, it also increases towards the pole, at which we have a peculiar phenomenon. Between the autumn equinox and the spring equinox, the Sun reaches the lowest altitude at culmination at polar latitudes, eventually never rising nor setting around the winter solstice, being always below the horizon. Then, dawn reappears slowly, until around the summer solstice, the Sun never rises nor sets again. It's the midnight sun, ever present above the horizon.